What's up, fellas? We got a new nozzle designed to test today. This is a silicon carbide nozzle that has an exterior diameter and dimensions that are the interior dimensions of the first test nozzle that I did. For you guys who are following along with me, my posse, this is what we've seen, this little one here. We're going to be testing this small one and this bad boy right here. This is the longer waste oil burner nozzle that's meant to burn waste oil. So let's get a look at this. But today we're starting off with a propane test. And the reason why I wanted to start off with propane was Robert left us an interesting comment that I never even took into consideration. Robert's definitely among the top 10 of intelligent commenters on this channel. Definitely has to be an engineer. I don't know what you do for a living, brother, but I do read everything you guys leave on here. So, for the most part, I have not yet encountered any issues with these things breaking from moisture. I did have a customer break one from zone heating. Heating up a small area on here, trying to get it to ignite, causes a circular expansion that will induce a circumferential crack around the nozzle and break it. These things are fragile. That is the downside. I'm almost wanting to take do a drop test and see how far you can drop one of them. You got to break a few eggs if you're going to make an omelet, man. Well, they're not very strong. I don't see any yolk for an omelet either, but hey, that's pretty fragile stuff, guys. So dropping these is out of the question. You've seen how I just barely did that. I took one for the team. But hey, believe it or not, you learn the most in mistakes in life than you do through success, and that's a fact. So we'll do one more little test here. Let's do a thermal shock test. We're going to get this hot, spray it with a little bit of water. I'm not going to get it like so hot. All right, I'm on board with this. Ooh, that's cool. Check that out, dude. That is awesome. Smarter Every Day would love this. So, it is very... Oh, we got a crack. It didn't like that. I think the moisture got inside of it and then exploded, maybe. Poor Vice. All right, no more omelets for the day. All right, fellas, so I'm just doing this test to show that an average torch only gets you to about 1920 degrees. That's it. All right, you get the point. It's not all that fancy. Yes, it's a smaller torch, but size doesn't really matter. I have a torch over here that will max that thermocouple out in about 10 seconds. I'm not going to do it because this torch will actually damage that thermocouple. It will melt that metal quicker and I'll have time to get the torch off of it. This is an oxyhydrogen torch that uses the electrolysis process to convert water into a very hot torch. I also pass acetone through it. That's an acetone infuser that actually cools the flame down and helps turn it into a reducing flame that's more suitable for the brazing process. So I'm going to finally shut up and let's fire this thing up. Okay, it's a pretty heavy formaldehyde production. Not good. New bolt placement. Okay, prior to me backing this nozzle off of the intake port, we were getting heavy formaldehyde production. It was burning my eyes, stinging my throat and nose, and backing this nozzle out of that gave us a little bit more secondary air, which is important because this siphon nozzle acts as a Ventura pump as well, pumping extra air into the burner. But we were too close for that to happen, and I think we were sucking backwash in a circular pattern from the combustion chamber back into the unit. And I wanted to bring up the formaldehyde production for a reason. This is a high temperature blowtorch. This thing could reach like 2,700 degrees Fahrenheit with just propane and compressed air. And one of the things I noticed during the development of this thing was I could cause it to produce copious amounts of formaldehyde. I'm talking huge amounts. And it may be a new process that industry is unaware of. And I wanted to run this by you guys. I know a lot of you guys are very intelligent viewers. I've been blessed with some great commenters, and I wanted to run this by you guys and tell me what you think. I don't expect no one to go out and do any research, but off the top of your head, if you have any input on the production of formaldehyde with propane, let me know what you think, because this thing right here on like extreme excess air can produce so much formaldehyde that it will run you out of the shop. Now, this isn't a very big area, but within seconds I had to bail. My eyes were stinging violently. It was, and I looked into it and come to find out I was producing formaldehyde on a tremendous scale. I mean, it was not your average formaldehyde production. Because of this vortex action, we had something very beneficial to the production of that chemical taking place inside of this device. There is a laminar flow tube system inside of this thing to kind of help streamline the flame out. Just experimenting. Hey fellas, I wanted to point one thing out to anyone who thought they might want to replicate the formaldehyde thing I was talking about. The air input was not configured like we're seeing right there. It was a cyclone system. The air spun around inside of there on a cyclone. So it had two tangential intake ports for the air and the propane. And I'm pretty sure that was a huge constituent of the formaldehyde production. I don't remember this particular arrangement producing formaldehyde. I just wanted to point that out in case one of you guys became very interested in that subject and wanted to attempt to replicate it. You would probably not produce those results with that particular configuration. I'll try and find the video and leave a link in the description. It's micro jet engine or something like that. That's my wall of dead animals, by the way. I've got a few up there and a whole pile of them out back. I need a dumpster. And today, once again, I encountered the formaldehyde production, and I just wanted to run that by you guys. This is what testing is all about. Now, I went ahead and just mounted this nozzle in the place that the other burners like it at, and that turned out not to be its home. We had to back that thing out a lot farther than normal. I may even revisit the whole mounting process on this thing because, again, certain fuels have their favorite position, especially with the Dragon Burner series. They have their own angle of attack even. So nonetheless, okay, that's a lot better than it was. Pretty cool. Oh, crap. Oh yeah, and the other cool thing about this test was our omelet. Broke a lot easier than I thought. I was hoping for at least a bounce. No. I'll have to check the footage, but I don't think that thing bounced at all. I think it literally melted into the ground like pudding. Pretty fragile stuff, but it's supposed to last longer than even 310 stainless steel, which is very expensive stuff. And it's kind of toxic to work with too. Let me give you an example. Back when I was a union carpenter, I would often get scaffold jobs in the power plant during outages, and the guy who was always grinding on the stainless steel burner outlets, I'm sure they were using 310 stainless steel on a power plant for that particular section, because there's areas inside the boiler where chunks of steel this thick start melting off of the pipe connections. So I mean, when you're burning for a year straight, you know. So anyway, that entire area would be cordoned off with hexavalent chromium signs everywhere, and the guy would be in full hazmat suit as he was grinding this stainless. So, and yet they got us all just wandering the area, of course. So anyway, pretty toxic stuff. So I visited that possibility of using these carbide nozzles. They can certainly withstand the heat a lot longer, and just wanted to see what happens with them. Just a test. All right, fellas, so the next couple of videos, we're gonna try this thing out on waste oil and diesel as well. I didn't want to cram it all into one video. We're already like 15 minutes into this thing. It's just too much information in one video, and it's also hard for me when I go back to write this book. I'm just digging through so much stuff looking for info. It's better if the title just says what I want. So next video, we'll do a diesel burn on this thing, then waste oil. Fellas, I also intend to get the wattage output of this thing, the BTU rating, whatever you want to call it. I prefer to go with wattage because the math is so much easier for me. I like the metric system when it comes to doing thermodynamics and stuff like that, or kinematics or kinetics, all that jazz. So what we'll do, as soon as I get more propane, I knew I didn't have enough to do a good test. So I'm gonna get another tank. We're gonna weigh the tank. We're gonna run this thing for 10 minutes at a particular setting. We're gonna weigh the tank again, do the calculations to get the wattage at what I perceive to be the hottest setting. And then what I would do is like get the wattage output of other settings and then take pictures of it. And all of this data is going to be used to populate the book that I'm writing. So it's kind of, some of this stuff isn't the most exciting thing to look at, but nonetheless it's going to make for some great information in this book. And I definitely want to have the wattage output of different settings. And I think that probably getting the wattage output of, say, the highest thermal output, which isn't going to be the hottest flame, by the way. The highest BTU rating will never be the hottest flame. It's probably about 60%, I think. You got to dump so much air into it that, I don't know, the flame just gets smaller. I could be wrong, but it seems to me I can get more heat with a lower temperature flame because I can put more fuel into the system. If I put too much fuel into my high temp flame, we lose temperature. So that's why I say that. There's times I'm actually backing off the fuel to increase the temperature. So we'll do the high temp, all that. Yeah, I'm just gonna shut up and we'll do that some other time. You guys got stuff to do, man.